Alright, tonight's video is going to look at how we measure earthquakes and the different ways that earthquakes can cause damage on the Earth's surface to buildings. So we'll start with how we measure earthquakes and then look at how they can cause damage. And first we just need to quickly define a term. An earthquake's magnitude, that term refers to the rating that geologists assign an earthquake based on its strength. So magnitude is just a rating of the earthquake based on its strength. The bigger the number, the stronger the earthquake. And now we'll look at three different ways that we can rank earthquakes. Right? Each one has its pros and cons, and we'll see which one we use today. So the first and oldest way to rank an earthquake is called the Mercalli scale, named after the gentleman who invented it. And it measures earthquakes according to the level of damage. Right? So no instruments required, super simple. Problem though is that the same earthquake can have different ratings because different places have different amounts of damage. And if an earthquake has no damage at all, then it's really difficult to rate it. So it's very subjective and it's not particularly useful, but it is better than nothing. And Mercalli scale went from 1 to 12. You don't need to memorize any of these intensity levels, but just to give you an idea, it goes from not being felt at all to damage total, waves seen on the ground, objects being thrown into the air. So in the 1930s, with some new technology, we were able to develop a better scale than the Mercalli scale to measure the strength of earthquakes, and that is the Richter scale, which I'm sure you're familiar with the term, and it's based on the size of an earthquake's seismic waves recorded by a tool called a seismograph. A seismograph is basically a little hanging pen, and as the earthquake shakes the room, the pen moves back and forth on a sheet of paper, and we can measure the strength of the seismic waves. And the Richter scale was much better than the Mercalli scale, but it only really works well on small, nearby earthquakes. A really big earthquake will totally overwhelm the seismograph, and far away earthquakes don't give enough information. So the Richter scale was great, but it's not really the best tool that we can have. And so this has the familiar ratings from 0 all the way on upwards. There is no maximum value, but the most we've ever recorded is a 9.6. But once you get above 6, you're talking about damage to structures. Anything less than 6, especially if a building is built to withstand it, isn't really going to be anything that's going to cause a lot of damage. So then in the 1970s, again with even better technology, we started to now be able to measure how much the fault moved, and we combined the Richter scale with these other measurements to create something called the moment magnitude scale. And this is what we use today. Even if on TV you'll hear them say on the Richter scale, it's the moment magnitude scale. This is what scientists use today. And this estimates the total energy released by an earthquake by using the measurements of seismic waves, just like the Richter scale did, but also the measurement of movement along the fault. So we can use GPS satellites to very, very accurately measure how much this fault has moved and get an idea of how much energy has been released in the earthquake. Right? And something important to note, that each step up in magnitude, i.e. going from like magnitude 3 to magnitude 4, means an earthquake is releasing 32 times as much energy. So a magnitude 4 represents 32 times more energy than magnitude 3. A 5 is 32 times more energy than a magnitude 4. So you can see as you start to get bigger numbers, we are talking about very, very large amounts of energy. And so let's pivot quickly and talk about how these earthquakes then can cause damage. There are 4 main ways. We're going to just quickly go over each one. The first way an earthquake can cause damage is just by the shaking. The shaking from the earthquake can loosen the buildings, can crack roads, and loosen foundations. So that's pretty straightforward. The next is something called liquefaction, right? Which sounds a lot like liquefaction and is basically what's happening. This occurs in loose soil, and it can turn that soil into mud, which will no longer support the weight of things on top of it. So you can see this gentleman is standing in front of his house, and in an earthquake, the soil under this side of the house underwent some liquefaction, and the house kind of sunk into the ground. Alright, so liquefaction is definitely a problem, say if you build your house on a riverbank, right, somewhere on loose soil, you can have liquefaction occur and the buildings will literally just sink into the ground. Not super fast, you can tell it's not really going far, but that's still damage that needs to be cleaned up. Our next one is the tsunami. Right? These are large ocean waves caused by the movement of rock underwater. So in an earthquake, a piece of rock, a very, very large piece of rock might thrust up into the ocean, pushing a wave out of its way, or a huge rock fall might collapse, causing a wave to move away from it. All right? These cause massive amounts of damage. Right? These are some pictures from the tsunami in Japan 3 years ago. Right? They're rarely huge tidal waves like the movies, right? You see in like Day After Tomorrow or movies like that, this huge wave towering over the buildings, and it doesn't really ever look like that. It's more like if the tide just kept going up. So you can see here, the tide has just pushed up this river and is now flowing over the wall that was built to keep the river off the streets, right? And you can see it's just pouring in. There's no big crashing wave. The water is just going up and keeps coming and goes very quickly. Right? And it's so powerful it can even carry large boats pretty far inland. Right? And then finally, our last way that we can have damage is aftershocks. Aftershock is just a small earthquake that occurs after the main one, and it can cause damage by shaking structures that were weakened by the original earthquake. So maybe this building would have been fine with a small magnitude 3 earthquake, but when you have a magnitude 8 earthquake to begin with, now your magnitude 3 earthquake can do some damage because the building has already been weakened. Alright, so those are the 4 ways that earthquakes can cause damage. Go ahead and put 3 questions at the bottom of your notes, and I'll see you guys in class tomorrow to start researching your design projects.